Now, every wire that you use has some sort of resistance. Okay, so the electrons E has some sort of resistance wanting to travel this wire. Okay, and that resistance is equal to rho L over A, right? Is that right? Yeah? Rho L over A. That's the formula, isn't it? Yeah. So that means the longer your length, because it's an numerator, the bigger your resistance. The smaller, the bigger your area, the less the resistance. Okay? Because it's at the denominator, it's inversely proportional. Bigger at the bottom, smaller as your answer. So that is why when we use bigger wire, yeah, thicker wire, it has less resistance and is an advantage. But what happens when you use bigger wire? It's more expensive. It's more metal. Okay. So if I was going to have a concert, and for let's say some in Wembley, all the wires need to be quite thick because the amount of current going through isn't going to be 13 amps. It's going to be like 20 amps. Okay, because it's driving a huge speaker that can smash windows. Okay, and so therefore this is why we must increase the area to lower the resistance to get more current through. Okay, so and when you buy any material wire, it naturally has the resistivity. Yeah. So if I go on the catalog, it tells me the resistivity of every single conductor. Okay. And that's what we need to find. Okay. From that answer, I can tell what material this is. Okay. But it doesn't tell you what material this is. So therefore, if they tell this is copper, I don't even need to do the calculation because resistivity of copper is the same. Okay. No matter what. So let's do that then. To so you can see that we need to find area. To find area, we are given diameter. So when I need the circumference, I'll use pi r square. Sounds like area to me. So you can either divide this by 2 to get area, to get radius, or you can always learn the engineering way, which is d square over 4. So there's 2 area you can use. But because engineers, we can't measure radius. It's always measure, side to side. So we always have diameter as our parameters, not radius. Okay. So this is the one that you, as an engineer, you should always use. When you were taught mostly that one at school, but this one is the engineer version. Okay. Again, we need to change that to meters. And so 10 millimeter divided by 1,000 is equal to 0.01 meters. Okay, so first thing I'm going to do is to find out the area first. Okay, so area is equal to pi times 0.01 square over 4. Now put that in the calculator and tell me what that is. Wow. Okay, in that case, I better read off of my own calculator in case I type something wrong. Okay, so there are 4 0 between the dot and the 7. Okay, let's write this out in full like this. Because it's meter square, obviously it's quite a small number. I mean, area of a wire is small, isn't it? Okay. You barely can see the cross sections anyway with your eyes. Okay. So now we got the area, but we want to find rho. So it's a good time now to rearrange a formula first. Okay, so rearrange formula. So this one, you have a go at this. See how many of you get this right. So if R is equal to rho L over A, what is rho equal to? What's rho equal to? Okay, so can you rearrange the formula to make rho the subject, please? Oh, Korea. Very good pen. It's good, isn't it? It's all right. Yeah. Okay. Yeah. Rearrange the formula just to say that at the moment we have 9 people got used in Unit 1 in the lower 6. Those people only answer 2 questions out of 20 questions in the exam. 2 questions. So you're sitting in the 80 marks exam, 2 hours, only managed to do 2 questions. Okay. So we need to make that change. So guys, this will take 2 seconds to do. Times both sides by A. Would you not agree? Times both sides by A. And then that A and A cancel out. And then divide both sides by L. So it's actually RA over L. I hope you got that right. Okay. So we got the A. Do we have the resistance? No, we haven't got the resistance. But we got the voltage and we got the current. How do we use V and I to find R? Times will give you power. P equals to V times I. Look here. Yeah? P is equal to VI, which is this one here. Look. That is the power if you times them. Look here. Yeah? So if we can do it like this, if you don't know how to rearrange, I is equal to V over R like this. So to find R is V divided by I. So we can then do V divided by I equal to R. So 9 divided by 1.9. Okay. So 9 divided by 1.9 is 4.7368 amp. Now you notice, why am I not rounding to 2 decimal places? Because I'm using this number to carry out some more working out. So I normally double my rounding. So that means instead of 2 decimal places, I round to 4 decimal places. Okay. So now we can substitute. So R is what we just worked out, 7.3, sorry, what am I doing? Yeah, ohms, sorry, ohms. 7368, and then times by the area, which is 0.000078539, divide by the length of the wire, which is 1,500 millimeter, divide by the 1,000. So like Tesla already said, at the start, he just convert everything into meters, and then he look at the question. So that's 1.5 meters long. Quite a long wire, okay? So then just type that in the calculator. So resistivity is 0.000248. And then there's a 0 there. So because it's less than 1, I round always with 3 significant figure, not 2 decimal places. Okay? Now, what's the unit? What is the unit for resistivity? I don't memorize stuff. So there's a way to work out what the unit is. What's the resistance unit? Ohms. What's area unit? Meter square. What's length unit? So meter square is the same as meter times meter. So that means at the bottom there's a meter. Cancel out with the top meters. So the answer is ohm meter. Okay? So the answer is ohm meter. That's your resistivity. So that's 9 marks done. And this is also a request from a student this morning wanting to know how to solve this problem.